Hello and good afternoon, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CompTIA Network Plus course, and this afternoon's video tutorial is going to be another activity that's going to continue to build on our IPv4 subnetting mastery, and we're going to be focusing on Class B addresses here. We're going to be looking at some ANDING and exclusive ORing, and this is going to become important because it's sort of a way to actually get a little deeper into the binary setup and how to sort of maybe shortcut things and figure out some information a little quicker than if you were to try to work everything out as we've gone through the 5 steps that we typically use. So let's go ahead and dive in here. You can see that we've got another practice activity here. So what class is the IP address? Well, it's 130. So remember that we said that Class A addresses, right? So when we take a look at Class A addresses, those are going to be from 0 to 127, right? Now, this is the technically correct and mathematically correct range. It's 0 to 127, but keep in mind that 0 and the 127, those are reserved. So we'll put RSVD. Those are reserved, right? So you can't use any IP that begins with 0 or that begins with 127 specifically for the purposes of, trying to set up your host, right? And remember, the all zeros is going to be the 0.0.0.0, and that typically will be used to represent the default route, right? And then 127 is considered to be the internal loopback range. So those two ranges can't be used. So now the usable range within the Class A addresses are going to be 1 to 126. And we kind of talked about this before, is that in some texts you'll see this 1 to 126 when they say what are the range of Class A addresses. And then other times you'll see 0 to 127. So keep in mind that this would be the usable range, and this is the entire range, right? So now if we know that we start at 0 at the low end and we can only go up to 127 on the top end, that tells us that the first 2 bits, high order bits in the octet, in the first octet, would have to be 0, and then you could have 1, 1, 1, 1, 1, 1, 1, 1. Is that right? 1, 2, 3, 4, 5, 6, 7. We've got too many ones in there. So 1, 2, 3, 4, 5, 6, 7, 8. So we've got, there is our maximum value, right? And let me scratch that out a little better there, where if you added 64 to 32 to 16 to 8 to 4 to 2 and to 1, we would get 127. And then of course the lowest value would just be all zeros, so then that would be simply 0. And so that's our range. So the first 2 bits, or I shouldn't say the first 2 bits, the first bit is always going to be this 0 bit, and then the other bits would change, and that would represent a Class A address. So for a Class B address, we talk about the range of 128 to 191. And there are no reserved, and this is the entire numerical range here. And so when we look at the first 2 bits, the first bit would be a 1, and then the rest of the bits can be all zeros. So I think I did too many again. 1, 2, 3, 4, 5, 6, 7, 8. No, we got it on the button there. So the first 2 bits would be 1, 0. Because again, 1, 0 in binary, this is going to be 128, and then everybody else is zeros. And then if we filled in the remaining bits here, right, those 6 binary bits, you would have 1, 0, and let's put a little squiggly here. You'd have 1, 0, and then 1, 1, 1, 2, 3, 4. So we've got 128 plus 32 is 160, plus 16 is 176, plus 8 is 184 plus 4 is 188, 189, 190, 191. So again, you'll notice that at the low order, or I shouldn't say low order, at the low number, 128, the first two bits are 10, and at the highest numeric value, 191, the first two bits are still 0, right? Okay. And over here, again, when we look, this was the maximum setup here. So the first two low order bits would be 0, 0 to start out, but then again, you can change that one to a 1. So here, that says the high order bits. The first two high order bits are going to be 1, 0, right? And then we can fill in the rest of the values. And then let's finish this out with class C. When we take a look at class C, we've got 192 up to 223. And so the first 3 bits, right, or I should say the first 2 bits, would be 1, 1, and then we would have a 0, 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. Because this is 128 plus 64 is 192. And then at the top end, for 223, it would be 110, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And so then again, we've got 128, and 64 is 192, plus 16 would be 208, 216, 220, 222, 223. And so that's how we end up with the values that we're working with. But again, you look here, the first 3 bits are 110. So here it's the first bit is 0. The first 2 bits are 10, and then the next 2 bits, or I'm sorry, then the 3 bits for the class C are 110. And that's how we end up with our ranges. So clearly the class of the address here is a class B address. The default mask in binary, 3, 4, 5, 6, 7, 8, it's a /16, so we're going to have 16 binary bits, 1, 2, 3, 4, 1, 2, 3, 4, followed by 16 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8. Now the default mask in decimal is 255.255, because all those ones add up to 255.0.0. Now we need 7 subnets. So in order to get 7 subnets, we know that we're going to have to borrow some of the host bits. So these, right, these bits and these bits, these are my host bits. So I've got 16 host bits, of which I need to borrow a few. So let's change to blue here. And remember that the number of subnets is going to be 2 to the n, where n are the number of host bits that we're going to borrow. So if I said 2 to the 1, we know that equals 2. 2 to the 2 equals 4. 2 to the 3 equals 8. And we can stop right there because we need 7. We're never going to get an odd number. And that meets the requirement. So we know that we need to borrow 3 of those host bits. So 1, 2, 3. And remember, we can't dive down into the middle of these octets. It has to be going from left to right. So we borrow the first host bit, the second host bit, and then the third host bit. So now we've got some questions out here. The new subnet mask in binary, well, we've got it right there. 2, 3, 4, 5, 6, 7, 8 dot 3, 4, 5, 6, 7, 8 dot 1, 2, 3. Those are our borrowed bits. And then we'll flip it back here to red and say 1, 2, 3, 4, 5, and then 1, 2, 4, 5, 6, 7, 8. So the host bits are in red down there. So what is the new subnet mask CIDR notation, or that classless interdomain routing notation? Well, it's going to be a representation of how many network bits do we have. Well, we've got a /19. Now, the new subnet mask in decimal would be 255 dot, we've got the all ones again, so this is the easy one, 255. But now we've got these 3 subnet bits here. So 128 plus 64 is 192, plus 32 is 224.0. So there is our new subnet mask. So we're going to highlight the rightmost 1 bit in the binary mask, and let's highlight that in green. So here is the rightmost bit, and this is what we call the golden ticket in terms of subnetting with Class B. And it's the golden ticket because we know that the value of that bit position is 32 for that bit position right there. And that becomes the block size. And with a block size that's known, at this point it becomes very, very simple to figure out what our subnets are going to be for this 130.213.2.7. So the number of possible subnets, well, we know that we've got it 2 to the 3, so that's 8. Number of possible hosts in each subnet. Well, that math is going to be a little more difficult because we're looking at a /19. So how many host bits do we have remaining here? We've got 1, 2, 3, 4, 5, 13 host bits, right, in a /19. So if we were to take a look at that, it should be 8192 for the total number of addresses, but we have to subtract 2, right? So it would be 2 to the 13 minus 2. And remember, we're subtracting 2 there, 1 for the network ID and 1 for the broadcast address. And so that should give us 8190, because 2 to the 1 is 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, right? And then we subtract 2, and that gives us 8190 usable host IPs. But again, the key here is this block size, because with the block size, I can now go ahead and pull together what the subnets, the individual subnet IDs are going to be. So 130.213, let's clear the screen here. And we're going to roll down now. So 130.213, let's remember that. So, oops, sorry. So fill in the information for the first 7 subnets and then the last subnet. So we'll turn the pen back on here. So the subnet ID, we had 130.213, and we'll start with .0.0. So now we know the block size is 32, right? So that tells me that the next address is going to be 130.213.32.0, and then .64.0, .96, whoops, .0, what do we have there? 128, 128.0, .160.0, and then we've got .192.0, and then .224, and it said leave this one blank, but we'll go ahead and fill it in there. Is that right? 32, yeah, 224, and then again, this would be .256. There can't be a 256, so actually let's do this. We'll clear that out there. We'll say .224, because that is going to be my last subnet, and we'll say leave that there. All right, so what's the broadcast address going to be? Well, remember, the broadcast address is going to be 1 less than the next subnet ID, so it would be 130.213.31.255, because the next one we move up, it would turn into .32.0. So the same thing here for the .32.0. The broadcast address would be 213. One less than this is going to be 63.255. And remember, the broadcast address is always going to be odd, right? That 255, it's always going to be odd. The subnet ID is always, let's get that A in there, always going to be even. We can see even numbers all the way down, right? So then for 64, it would be 130.213.95. 255.255. And then we've got 130.213.127.255. And then we have 130.213.159.255. And you'll notice that these are going up in increments of what? Exactly 32. So I don't even need to look over here for the next one. I could say 213 and add 27. Add 32 to that value right there, which would give me .191.255. And the same thing, add 32 to this value right here, 223.255. And again, the same first two values for the first two octets. And then finally down here, and again, this is, I'm going to leave that blank, so we'll scratch that out there. All right, so we're going to come down here to the final subnet, which would have been 130.213.2 what? If I added 32 to that, 255.255. Now, valid host IPs, we're just simply going to say .0.1 all the way to the IP right before this, .31.254. And then the same thing, .32.1 to .63.254. In fact, the right side here is pretty easy, .95.254. It's just the IP right before the broadcast address. Oops, sorry, .127.254. .159.254, .191.254, and then .223.254, and finally .255.254. And we know the first address is pretty easy, .64.1, .96.1, .128.1, and then we've got .160.1, .192.1, and then .224.1. Again, remember that the first two octets, the 132.13, I just left those off here for brevity. But it's the same first two octets all the way down. And so there's your first 7 subnets and the last subnet that we would have been working with, because we created 8 different subnets. All right, so let's go ahead and clear the screen. And now we're going to take a look at maybe a little bit of a shortcut here when we talk about combining binary numbers, right? So we can do ANDing or ORing. And if you take a look at the example that we have here, when you're talking about doing ANDing, right? If it's 0 and 0, it results in a 0. 0 and 1 is a 0. 1 and 0 is a 0. The only time you end up with a value of 1 is when it's a 1 and a 1. That results in a value of 1. So if we're doing ANDing down here, it says use ANDing. So you can see 1 and 1 results in a 1, and that results in a 1, because we're ANDing these two numbers here, right? Or I shouldn't say numbers. These two binary digits are being ANDed all the way down. So basically we're comparing that number with the number right below it. So here we have 0 and 1. Well, when you're ANDing, if it's not 1 and 1, it's 0. Same thing here. 1 and 0 is a 0. 0 and 0 is a 0. 1 and 0 is a 0. 1 and 0 is a 0. Remember, the only time you end up with a value of 1 is when it's a 1 and a 1 that you are ANDing together. So here's another example. So 1 and 1 gives us a 1. 0 and 1 is a 0. 1 and 1 is a 1. And if it's not 1 and 1, if you look down the rest of the way here, if it's not 1 and 1, they're all zeros, okay? And that's when we're talking about ANDing. And the only way to get the value of 1 is if you're ANDing two ones. Other words, it's going to be, or if it's not 1 and 1, it's not going to be a 1. It's going to be a 0. All right, so fill in the binary result. And let's see here. Let's come down a little further. We'll get the rest of the page in here. There we go. So let's fill in the result here. Again, very straightforward, not too difficult at all. So we're ANDing. So again, if it's 1 and 1, it's a 1. If it's not 1 and 1, it's a 0. 1 and 1 is a 1. 0 and 1 is 0. 1, 0, 0. 1, 0 is 0. 1, 0 is 0. And 1, 0, 0. Because the only two places where we have a 1 being ANDed, with a 1 is right there. There's two places in our exercise here. So our result would be 1, 0, 1, 0, 0, 0, 0, 0. So let's take a look at this next example down here. So we've got 0, 1. We know that's a 0. 0, 1, 0. 1, 1. Aha. There's the only combination that will result in a 1. 0, 0, 0. 1 and 1. That gives me a 1. And then we look at the last three here, 0, 0, 0, 0, 1, 0. Pretty easy, right? So the only time you need to be on the lookout here when you're ANDing is when there's two ones that you're ANDing together, because that will result in the value of a 1, right? So we get 0, 0, 1, 0, 1, 0, 0, 0. And that is it. ANDing is not that difficult, right? Very straightforward. All right, so let's take a look here. And again, this is sort of the use case, right? Because you're probably wondering, well, that's great that you showed me how to do the ANDing, but when would I ever use something like that? And so here is really the ultimate use case for the ANDing is that you can find the subnet address of a specific host by ANDing the host IP and the subnet mask together. So if you know, and let me see if the bottom of the page here, all right, so we've got the bottom of the page is going to be there. Let me see if I can squeeze this all into one frame. So again, if you know the subnet value, right, is a /27, you can easily represent that in binary. And then you can easily represent the host IP in binary. And we've done many exercises where we take the host IP and we put it into binary. We've taken the subnet mask, which is a lot easier to put into binary because we just go from left to right and we fill in. But the question becomes, if you were simply shown this and said, give me the subnet mask, or I shouldn't say the subnet mask, if you were shown that and said, give me the subnet address, right? What is the network ID for that IP address and subnet mask combination? What is the subnet address or the network ID? There's really the only way we've talked about to this point in the course would be to say, okay, well, I've always been told to get to the block size. So what is my block size? Well, this is a class C address here. So it's a /24 by default. We've got 3 bits that have been borrowed. The rightmost bit value is 32. So my subnets are going to be .0, .32, .64, .96, and so on for the 8 subnets that are going to be created. Now, when we look at this address right here, we can see that it's the actual subnet address is going to be .3.192. So I would literally have to continue on here, 128.160.192.220. What am I doing here? 32.224. Sorry about that. So what do we have? 1, 2, 3, 4, 5, 6, 7, 8. So I'd have to work my way all the way down to the next to last subnet ID to be able to figure out and say, oh yeah, the IP address 217 would fall in here somewhere. Now, with a /8, it's not that big. I'm sorry, /8. With a /27, it's not that big of a deal because we only have 8 total subnets. So for me to add 32, starting from 0, 32, 64, 96, to do this 8 times, that's not that big of a deal. But what happens when it's a /29 or a /30 and you're trying to figure out what is the network ID going to be? That might be a little more difficult of a proposition for you to figure out. And so that's where the ANDING can become very, very helpful, becomes a very important tool in your toolkit, especially if you're shown the IP and subnet mask values and asked, okay, give me the subnet, said the IP address and the subnet mask, and asked to give you the network ID or the subnet ID, right? So let's go ahead and do an exercise right here. So we've got this class C address, 192.16.23.223. It says convert the host IP address and the subnet mask to binary. Well, we're dealing with a /28. So we know we're going to have 16 subnets right out of the gate. So now this becomes a little long-winded to try to sit there and figure out what are the 16 subnets going to be until I get to the one between which my IP address is going to fall. So let's do it in the binary fashion. So if I were to go ahead and say 192 in binary is going to be 1 1 and then 6 zeros, right? 2 3 4 5 6 1 2 3 4 5 6 7 8, and then 16 is going to be 0 0 0 1 1 2 3 4, and 23 is going to be 0 0 0 0. I'm sorry, actually that'll be a 1 there. And then 8 would be 24, so that's going to be too many. And then we've got 20, 21, 22, 23, dot 223. So 128, 192, it's not going to be the 32, that'd take us to 224. So we're at 192. Well, 192 plus 16 is going to give me, what is that going to be? 208. And then we're going to have 216, 220, 221, 22, 223. So there's the IP in binary. The subnet mask is a /28. Again, the subnet masks are kind of easy to work with here. So 1, 2, 3, 4, 1, 2, 3, 4, dot 2, 3, 4, 1, 2, 3, 4, dot 1, 2, 3, 4, 1, 2, 3, 4, dot. Now we're into where we've borrowed some of the host bits. So the first 4, 1, 2, 3, 4, and then 1, 3, 4. So there's our subnet mask in binary. We've got our IP address in binary. Now we simply take our time and walk through and do the ANDing. And again, we look here at this first octet. Only the first 2 bit positions are 1s. So it's going to be 1, 1, and then 1, 2, 3, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8. There we go. We look here, we only have a single match of a 1 and a 1. So it's going to be 0, 0, 0, 1, 0, 0, 0, 0. Right? Pretty easy. Same thing over here. We've got the last 3 are 1s, and then this middle 1. So it's going to be 0, 0, 0, 1, 0, 1, 2, 3. And then here we've got the first 2 are 1s, and then we've got 0, and then 1, and then 0, 0, 0, 0. So now all we need to do is figure out what these values are down here that are in binary in each of the octets and convert them into decimal format. So the first one's pretty easy. 192. We look at the next one here. Only the 16-bit position is on, so it's 16. In the last one, we've got 16 plus 4, 2, and 1. In other words, 16 plus 7 is going to be 23. And then we've got 128 plus 64 is 192 plus 16 is what? You've got it. 208. 192 and 16 is going to be 208. And that is my subnet ID. So let's double check it. So the block size of a /28, and this is a great way to double check. The block size of a /28 is going to be 16. So we start out with, we'll come up here to the top. So we've got .0, .16, .32, .48, .64, .80, .96, .112, .128, .144, .160, .176, .192, .208, .224, .240, and again, if we added 16, we'd end up with .256, and we know we can't go up to 256. So if you take a look here, there is our subnet ID. Now, our IP address is 23.223. That's the host IP that they're talking about. So where would it fall? It would fall before that IP address right there. And in fact, if we take a look at this, what are the IPs in that range? So the first IP, or let's say the subnet ID, is going to be 192.16.23.208. So the first usable IP is going to be .209. However, the last usable IP is going to be what? Exactly, 222, because my broadcast address is going to be that 223. So technically, the host IP is actually a broadcast address. Whoops. So that is technically a broadcast address, right? So when looking at this, remember that that's going to be our broadcast address, because the next address up is going to be 192.16.23.224, and that is the next network ID for the next subnet, right? Or you can call it a subnet ID. So here is the subnet ID we were searching for, and we know that that is going to be the broadcast address. Okay, so let's clear the screen here, and I believe that is everything we've got. So again, we talk about ANDing the IP address with the subnet mask in order to quickly figure out what our subnet ID is going to be. So let's give this one a go right here. Let's do a little additional extra credit right here. So I'll put the IP in binary here. I'll put the subnet mask here, and then we'll see how quickly we can figure this out. So 130, well, it would be 128.0.0.0, and then 0.0.1.0. 4, 5, 6, 7, 8. That's 130. Dot, we need 213. So 128, 192, that would be 224. So that's going to be a 0. So 192 and 16 is going to be 208. We only need 5 more. So 0, 1, 0, 1. And then we've got 2, right? That's pretty easy. 1, 2, 3, 4. And then 7. Same thing, pretty straightforward. 1, 2, 3, 4. And then 0, 1, 1, 1. So we were talking about we need 7 subnets. So we're going to stick with this here. So 7 subnets gave us a /19. So /19 is the first 19 bits are all going to be 1s. I'm trying to line these up the best I can here. And then 1, 2, 3. And then for us in the subnet mask, everything else is a 0. 0, 0, 0, 0, 0, 0, 0, 0. All right, so here is where we're going to get our value for the subnet ID. All right, so we look up here. We've only got 2 in the first octet here, only 2 1s that line up. So it's going to be 1, 0, 0, 0, 0, 0, 1, 0. followed by 11010101 dot. And if we look in here, that's all, you guys see this, right? This is all zeros the rest of the way through. 1, 2, 3, 4, and then same thing in the last subnet, last octet, sorry about that. 4, 1, 2, 3, 4. So this is my network ID. So if we add these numbers up here, we get 130 dot, and now we've got 128, 192, 208, 208 plus 4 is going to be 212, 213 dot 0 dot 0. And that IP address definitely falls into the first subnet ID range, right? The first subnet range. Because if we're doing a /19, our block size is 32, which means the next network ID or subnet ID would be .32.0. So, does .2.7 fall between these two subnets, specifically in that subnet ID range? And it does. So it works not only for Class C addresses, but it's a very quick and easy method to sort this out when you're trying to use Class B addresses as well. All right, so this is going to wrap up the Class B subnetting, and then we took a look at ANDING in order to quickly determine what the subnet ID would be by ANDing the binary version of the IPv4 IP address as well as the subnet mask. All right, guys, thanks so much for watching, and I will see you all on Tuesday night.